Hey guys, it's Miss Johnson, and I am here to bring you our notes for Unit 1, Notes 1, which is on stem and leaf plots. We are kicking off Unit 1 today, and in Unit 1, we are talking about a bunch of different data displays. So the first data display that we are going to work on is stem and leaf plots. So stem and leaf plots are, it's a method of sorting data and arranging data to reveal the shape of a distribution, to reveal where your data falls within the range of the data. We're going to sort the data according to a pattern. We're going to split stems and leaves. We split our data into two groups. One is called the stems, one is called the leaves, hence the name of the plot. We don't put any decimals or commas in the display, so we will just have the numbers in there. A lot of times there's decimal points or commas in our data, but we don't use those in our data display in the stem and leaf plot. We take all that stuff out, but we will have a key, and that's where you know where those commas or decimals may go. So every stem and leaf plot must have a key. And that will tell us what our data set looks like. So there's a few nice things about stem and leaf plots. There's a couple of things that are really beneficial for us. One of them is if you turn the stem and leaf plot on its side, you can see the distribution, and it turns itself into a histogram. So a stem and leaf plot looks kind of like this, where you've got your stems down here, and then you've got your data points coming out here this way, depending on how many are in each stem. If I took this whole stem and leaf plot and I turned it on its side, it would become a histogram. So like these would be my two axes, and we'd have a histogram of our data. We would see how many is in each interval. Stem and leaf plots are typically set up by intervals. So a histogram and a stem and leaf plot are very closely related, and one actually becomes the other when you take the plot and turn it on its side. The other thing that's nice about a stem and leaf plot is that it retains its original data set. This is rare. This doesn't happen with a lot of data sets or a lot of data displays. A lot of our data displays take things and kind of summarize it for us. A stem and leaf plot retains the original data, which is really nice. Something that doesn't happen very often. So in our stem and leaf plot, we have two parts to it, the stems and the leaves, and again, hence the name. Stems are the left digits. They are the left-hand side of the number. Could be one digit, could be multiple digits. The leaves are going to be the very rightmost number. So whatever the rightmost number is, that's what your leaves will be. All right, so let's take a look at example 1. It says, list the data set used to create the stem and leaf plot. So we are going to work a little bit backwards here. We're given a stem and leaf plot here. One thing to note is the key. Here's our key. And we are going to recreate what this data looked like. So the reason the key is so important is because it tells us what the stems and the leaves are. So I know that in my stem, in between each stem, I have a little decimal point. So basically every single one of these things would have a decimal point if I was going to rewrite out the number. So for this first row, and then each one of these digits is an individual leaf. So for this first row, I have let me switch to a little better color. I have 4.88, 4.88 again, 4.89, and 4.89 again. So I had the 4.8 from the stem and then the 8 from the leaf. 4.8 from the stem, another 8 from the leaf, 4.8 from the stem, a 9 from the leaf, 4.8 from the stem, and another 9 from the leaf. So if I look at the next row down, I have 4.90, 4.93, 4.95, and 4.97. My next row down is 5.02. The next row down after that is 5.10, 5.11, 5.11 again, and 5.12. Now, this next row, I want to talk about this one. This one looks a little bit different. There are no leaves here. There are no leaves in that row. Resist the urge to create data. If there are no leaves, that means there is no data. So that's a note you could write down. No leaves means no data. So don't call it 5.20 because that's what a lot of people want to do. They want to call it 5.20. Up here in the row above it, I had an actual 0 for a leaf. That's where my 5.10 came from. But down here in the 5.2, there is no 0. There's no leaf at all. So then there is no data in that row. Now, we can't skip any sequencing numbers, any stems that are in the sequence. So notice that these stems go from 48 up to 54. I can't just skip one. You have to think of this whole thing as a number line. Okay, if this were a number line, you wouldn't just skip a digit. You have to count every digit. So even though there's no leaves there, I still have to put the stem. But resist the urge to say that there's any data in that row, because there's not. All right, let's go on to the next one. So 5.32, 5.36, 5.38, and 5.38 again. The last row, 5.41, 5.43, and 5.45. All right, so there's our data set. Our data set is all inclusive right here. One thing that's kind of nice and one thing that is good to check. Do I have other colors here? Oh, no, that's not what I wanted. How do I undo that? Sorry, undo that. One thing that is kind of nice is to check your N. So if I count the number of leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, that's the number of data points in my set. And that's a note that you could make as well. N is a number or is a variable that we're going to talk about every year or every day in this course. We're going to use N a lot. So N is the number of data points in your set. So when I count the leaves, I counted that there were 20 data points. You can spot check your data set that you wrote over here and just make sure that you got 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know I accounted for every data point. Now that doesn't necessarily ensure my accuracy, but it at least tells me, yep, I didn't skip anything. I got all the data points that I needed. Okay. All right, so that's the original data set from this stem and leaf plot. Let's go the other direction. Now we're given a data set and we are going to turn it into a stem and leaf plot. So one thing that is helpful to note, again, we're going to use this in every data set that we look at, which is going to be pretty much every day. Let's count our N. Let's figure out how many data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my N here is 16. The next thing to take note of is to make sure that I appropriately label my stems. So all of my data has a tens place and a ones place. If I look for the lowest one, my lowest one appears to be 42. And if I look for the highest one, my highest one appears to be 99. So I'm going from 42 up to 99. So what that tells me is that my stems, I'm going to split the tens and the ones. And I'm going to start with a stem of 4, and I'm going to go up to a stem of 9. So if I start my stem and leaf plot, it's going to look like this. I have a stem of 4, 5, 6, 7, 8, 9. Okay, so there's my stems. And I know my stems are the tens place. You don't necessarily have to label these because you're going to put a key that's going to tell the reader of the data display what your stem and leaf plot is, but just for our purposes, I'm going to tell you where I got that. So then here's the next thing about the stem and leaf plot that is important to take note of. So for each individual stem, I need to label my leaves in numerical order. So I'm going to start with the stem of the 40s. Now I'm going to look through all of my data and I'm going to find the 40s. So there's a 42 and I don't see any other 40s. So the only leaf that I have next to the 4 is a 2. Let's move on to the 5s. If I look for 50s, if I go down my line here, the only 5 that I see is the 56. So my only leaf would be a 56. Now let's look at the 60s. So in 60s I have, so I know I'm done with the 42, I know I'm done with the 56, and you can do that. You can cross off your data points once you've marked them. Once you've taken note of them, then you know you don't need them anymore, you can go ahead and cross them off. You don't have to, but for some people it's nice to keep track of. So let's look at the 60s. So when I'm in the 60s, I have 67, I see another 67, so I have 2 7s and that's it. So I'm going to have 7, and I need to list it twice because there are 2 of them. Okay, so I'm done with that, done with that. Let's look at the 70s. 70s, I have 73, I have 78, I have 77 and another 78. So here's where I need to be careful. I have to list these leaves in numerical order. So my lowest one is a 73. That's my first 70. Then I have a 77. So I'm going to list my 7. Then I have the 2 78s. So I'll list 8 twice. So notice that even though they're in a different order in the data set, when we listed it up here, I put them in numerical order in the stem and leaf plot. Then let's go to the 8s. So I'm done with the 70s, I got the 70, I got the 70. If I look at the 8s, I've got 84, 82, 86, and another 82. So I have 2 82s, and then I have an 84, and then I have an 86. Okay, 4, 6, 2, and where'd that other one go? There it is, 82. Okay, and then my 90s, I got a 99, I have a 91, I have a 94, and a 91. 2 91s, a 94, and a 99. Okay, there's all of my data. I got the 99, got the 91, got the 94, and I got the other 91. So there's all of my data. It's all listed. This was the tens place, this was the ones place. And again, you don't really need those labels because the next thing that we're going to do, which is a requirement for all stem and leaf plots, is we have to make a key. Okay, so you have to make a key. Some people call it a legend. Sometimes you'll see it listed as a legend, but it's usually called a key, or sometimes you'll just see the numbers off to the side and they won't even have it labeled. Either way, you have to signify what these stems and leaves mean. So the way we do that is we do 4 with the stem, or with the line, and then the 2 is equal to 42. Okay, now it doesn't matter which data point you pick. You could have picked any data point in the data set. Sometimes you'll see the first one used, you'll see 73. Sometimes you'll see the last one in the stem and leaf plot, so it would be 99. It really doesn't matter. I could have made it the 82 or the 56, doesn't matter. As long as you have this, okay, this is a must-have. As long as you have that, then you're good. Okay, all right, on. So let's talk about back-to-back stem and leaf plots. So sometimes we have 2 data sets that are closely related to each other that we want to show together. We want to take those 2 data sets and we want to compare them, and we want to look at them in the same place. So what we can do is use a back-to-back stem and leaf plot where the stems are in the middle. Sometimes you'll see where stems are in the middle and one data set comes out here and one data set comes out here. Okay, so they use the same stems, they share stems, all of them would be the same, but they're leaves go off in different directions. Practice making one of those bad boys. Okay, so we're going to just read this one here. In example 3, it says, what conclusions can you draw from the back-to-back stem and leaf plot? This back-to-back stem and leaf plot shows the pulse rate before and after. It doesn't say before and after what, doesn't say what's happening, and you are supposed to gather some information between the 2. This is a comparison type model. We're able to compare these 2 data sets because we're looking at them on the same plot. So we can see that before, a pulse rate went from about 68 up to 110. After, the pulse rate went from 86 up to 124. One might suggest on the very basic level that pulse rate increased. Whatever was going on, the pulse rate increased. Some people might say that it was some athletic activity or exercise that was going on. Okay, so some sort of activity occurred where the pulse rate increased from before and after. you could see that the shapes are relatively the same. If I was flipped these two and looked at them on the side, that second stem down is the longest one for both of them. This first stem is the same length. And then they're not exactly identical, but they're pretty close after that. So the shapes are similar. So you'd like to say that the pulse rate increased roughly the same for each individual thing that they're looking at. I mean, this could be people, this could be animals, who knows? So anyways, a couple of things that you can look at to compare the two data sets. So now let's construct our own back-to-back stem and leaf plot. If we want to construct our own back-to-back stem and leaf plot, again, we have our stems down the middle together, and then we put our leaves off to the side in either direction. So let's take a look at our two data sets. And that's part of the thing about a back-to-back stem and leaf plot is you have to look at both data sets before you decide your stems. So if I look at the data set that's in purple over here, I wonder if I have a purple. Do I have a purple? Where's my purple? Oh, come on. There, let's try something like this. Done. Okay, so if I look at this purple data set, I see that I have 5.34, 5.79, all the way down, 5.46. Everything is 5 point something. So that tells me that those are going to be my stems. My lowest one is the 5.10, I believe. Yep, I don't see any other ones. My highest one, I see 5.79. So I know I need to have stems from 5.1 up to 5.7 for this data set. Now let's look over at this green one. In this green one, I see that my data is again all 5 point something. My lowest one appears to be this 5.29, and my highest one looks like 5.62. So I need to go from 5.2 to 5.6 for this green set. My purple set has even more stems, so I know I need to have all of those. So my stems are going to go from that 5.1 up to 5.7. So if I fill in my stems in the middle, I have 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7. So there's all of my stems, and then each data set goes in either direction. So I'm just going to do this purple set out to the left, and I'm going to do the green set out to the right. So for the purple set, let's go through and plot our leaves. So my first stem is 5.1, my data point is 5.10, and there's no other data points that fall under that stem, so I'm going to just have a 0 here. Then I have a 5.2. The only one that I see is 5.27, so my only leaf here is that 7, because again, here's your 5.2, and there's the 7 that goes with it. Then I have the 5.3, so I'm done with this, done with that. Let's look at the 5.3s. I have 5.34, 5.39, and 5.34 again. So I have 2 4s and a 9. Now notice that I'm working from the stems on out. It's a little weird when you're doing a back-to-back stem and leaf plot because one data set you have to read backwards. So like I start next to the stems and I work my way out from there. So when I'm going to the left, it's like you're reading right to left, which is different than how we read a book. Normally we read left to right. So the left-hand side goes backwards, which is kind of interesting. So I'm done with the 3s. Now let's look at the 4s. I've got 5.42, 5.47, and 5.46. So I have a 2, a 6, and a 7. 2, 6, 7. Then that was the 4s. The next one would be 5.5. Now I don't have any 5.5s in this data set. So I'm going to skip that stem. Resist the urge to put a 0. There is no data in that set, so you put no leaves. No data means no leaves. I'm going to go down to the 5.6. 5.6, I have 5.63, so I have a 3 there. And then 5.7, I have that 5.79, so the only leaf that I have there is a 9. Now again, it's good to check your N. Over here I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My N was equal to 10. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, N is equal to 10. So if I count my leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I had 10 leaves. That leads me to believe I got all my data. Great. great. Okay, let's do the green one. Over on the green side, again, I'm starting at 5.1 and I'm going up to 5.7. So 5.1, I see no leaves. So I can skip that one over. And again, resist the urge to put any data because you don't have any data there. So then the next one, 5.2, I see a 5.29 and I see another 5.29 and that's it for those. So I have 2 9s there. So there's that, and we're done. Oh, see, and then I just put them in the wrong spot. Come on, Johnson. Let me get my eraser, sorry. Let's fix that. Oh, that's a really small eraser. Here we go. Okay. So I have my 9s down here next to the 5.2. Okay, 5.3. I have 5.36, and that's it. So I have a 6 that goes there. 5.4. I have a 5.44, so I have a 4 for a stem, and that's all that goes there. Then the next one, 5.5. There's a whole lot of data in this one. I've got 5.55, 5.58, 5.57, and 5.53. So I have a 3, a 5, a 7, and an 8. 3, 5, 7, 8. 5.6, I see 2. I see 2 and 6.5. Oh, and that wasn't even my biggest one. 5.65 was my biggest one. Whoops, I misspoke on that before. So 5.62 and 5.65. That's okay. It didn't change my stems, so I'm okay there. All right, so then let's spot check. Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 on each side. I think I've got all my data. So now if I wanted to compare these two, I could take a look at the left side compared to the right side and see what happened with my 2 data sets. Was this something that took place over time? Was this 2 different groups of people? Lots of times we are comparing gender, male versus female and things like that. So yeah, so there's that. Last but not least, and in fact, some people even choose to do this at the beginning right away so they don't forget it, because notoriously forgetting the key is so common. People forget to put a key on their stem and leaf plots all the time. But last but not least, we need to leave a key. So the key, and I'll just use the 5.29. It doesn't really matter. So 5.2 and the 9 is going to equal 5.29 in this data set. So, all right, that is going to take us to the end of our lesson for today. So thanks for listening, and go ahead and work on your practice assignment, and I will catch you next time.